if anyone has a burning item that they would like to add to this breakout discussion, please feel free to come on camera and unmute and share it with the group. And I guess alternatively, oh, sorry, go ahead, Gail.
I wasn't going to actually add anything, but it would be helpful if we maybe repeated those topics.
Sure. I was just going to jump in and say that if there are no specific items that the group wants to suggest, I'm happy to kind of revisit some of the ones that were mentioned this morning, and then we can potentially pick and choose. So I won't share them. I'll just read them off if that's okay. So, the first highlight that Irina had mentioned off the top was the reframing of unmanaged versus managed wetlands. And so again, this is a pretty substantial topic with respect to national greenhouse gas inventory reporting. And I think could be a really interesting piece of work going forward on how to frame that nationally, specifically in agricultural environments. The second topic was around the essentially long-term difference in signals down core within some of these wetlands. So when you're looking at drain versus intact versus restored wetlands and the differences in those soil profiles and the length of time it takes to essentially reaccumulate carbon or nitrogen and phosphorus. And again, that's one area that I don't think has been extensively explored in Canada. There's been a lot of work done in the US, not nearly as much work done in Canada. The third highlight was around closing the carbon budget. And that, I think, speaks specifically to one of the objectives, and objective 2 that we haven't really tackled, which are some of these lateral flows. And as Irina mentioned, we're focusing a lot on the vertical flows, but there's a lot of lateral flows coming into wetlands, even isolated wetlands that we're not currently documenting, as well as some of the biological fluxes that we've also talked about in terms of organisms emerging and being embodied carbon in the food web. The fourth highlight was around looking at, for example, beyond carbon. So again, lots of the work focused here is on understanding carbon balance, greenhouse gas emissions. Obviously, these wetlands provide a whole host of other services with respect to both mitigating and adapting to climate change. So whether that's looking at the biophysical impacts of wetlands on climate and the cooling impact they have, or some of the other ecosystem services associated with these wetlands, again, that will help us adapt and mitigate against impacts of climate change. So even just thinking about things like biodiversity and the fact that lots of these prairie wetlands and wetlands in general don't have the ability to migrate with the changing climate. The fifth piece was around prioritizing wetland retention over restoration. Again, this has been a pretty common theme in the literature in other jurisdictions. I don't think it's been fully explored here in Canada. Again, Irina is correct. There is a default position with a lot of conservation program to look at restoration because it's additive, incremental, and it's easy to show that impact, as opposed to conserving wetlands that are potentially at risk, which becomes a little more problematic in terms of accounting for things like leakage. The sixth highlight, I think, was, the sixth highlight was focused on building a multifunctional wetland assessment framework for policy and planning. So just another idea in terms of developing tools that can be used, across stakeholders for looking at wetland function and valuation. The seventh highlight was, and this is one that I'm particularly interested in, is again looking at regionally specific emission factors for freshwater mineral wetlands. Again, I think this is something that is of interest, especially with respect to national greenhouse gas inventory reporting within Canada. Again, we've talked a little bit about the fact that there's currently just one default emission factor, and when we compare it to the measurements that we're currently making, it seems to substantially overestimate greenhouse gas emissions from most of the wetlands in the Canadian agriculture context. So again, now with the network that we built out, I think there is a capacity to essentially synthesize that information into regionally specific and potentially land use context default emission factors for some of these wetlands. Now, Irina, those are the 7 I had. I can't remember if there was an 8th that you had potentially incorporated. Okay. So those were some of the highlights and some of the main topic themes that we had talked about and that had flowed out of some of the data shared on day 1. Again, happy to hear other suggestions from the group, or if you have particular interest in any of those topics that we've just listed, we can start listing these and potentially voting on them. Okay, Gail, I see you have your hand up, so please go ahead.
Thank you for all that, because my short-term memory when I'm dealing with all kinds of things is not great, but I see what was 2 long-term differences in signals and 5 being, to me, related, because one was seeing what it was like. People kept talking about Reco's work, and I have some comments about that, which is why I'd like to be included in whatever group I was an external on that. Because long-term difference in signals actually relates to carbon sequestration, etc., after restoration. I think.
Yeah, that's a good point. I think those do go hand in hand. So looking at the long-term differences in cores would essentially inform whether you're prioritizing retention over restoration and how those systems behave over time. So that's a good catch. I do think that those could be looked at.
So that reduces us
simultaneously
to 6 potential topics now. And I would be happy to join those 2, because I see that I've been thinking about that a great deal with salt marsh restoration, which is not so different when we consider this broader perspective for all wetlands.
That's a problem kind of and I'm diverting the discussion, but I'm trying to basically get a project off the ground to look at the emissions effect of cover crops. And so here, in the Canadian context, if you go regionally, you can find that farmers do all kinds of cover crops and cover crop mixes. And the problem then becomes that there is no database to kind of go to that level of detail to ask a farmer, could you tell me what cover crops did you seed and how much did they grow and what is the distribution of them at a certain time when they're basically full grown? And so the problem then becomes that you have to overlay a kind of simplifying framework that says, okay, we recognize that there's going to be differences in cover crop mixes the farmer grow, but they have an ultimate function with respect to emissions that one type adds nitrogen to the system and the other one kind of stores and pulls out nitrogen from the system. And as long as you can kind of fit things into these 2 categories, you also have a question that you can ask on a national context. So I know from the research side, it would be interesting to drill down to the very last level of detail, but in a national accounting context, we probably have to sum things up into categories that are somewhat representative, and there may be things that don't quite fit there and others that maybe not at all, but they may not be that necessarily relevant either.
Okay, thanks for that, Roland. Gail, does what I've captured here under one align with what you were thinking with respect to combining long-term differences with prioritization of conservation versus restoration? Okay. Any other suggestions, recommendations from the group?
Pascal, I just want to draw your attention to the chat, and also I was also thinking along the same lines as Christian, although he put that he was interested in the carbon lateral flows into and out of, as well as the economics. And I'm wondering if we could combine closing the carbon budget and as together with the building the multifunctional wetland assessment tool, because they're related. In fact, when we do the assessment tool, we'll want to be able to quantify all of those carbon fluxes to be able to get it right, but then we can add some of the other benefits to it. So thinking in the idea of simplifying and merging, I would suggest, if others want to jump in, that we might be able to combine those into a second topic. And I also want to acknowledge Sarah being interested in the beyond carbon, looking at the cooling versus carbon topic.
Okay, that's great. Yes, and that's the other piece here. Once we identify these topics that we're going to break out into, we're also going to want to have rapporteurs for each of these topics. So we'll also be looking for people to self-identify. So hopefully, I'm not sure if this is captured, what you brought up, Irina, in terms of merging, essentially closing the carbon budget with the multifunctional assessment of wetlands. I think that makes sense, because in that way, even if we're not able to capture all of the wetlands functions initially, at least we have this base place to operate from and then evolve that over time. Okay, so that's two. We'll take a couple minutes still to take additional suggestions from the group. Again, we're aiming for a maximum of 4. We can default to these 2, but willing to listen to the group in terms of potential other suggestions.
Again, Sarah had put something in the chat, Pascal.
Okay, am I not scrolling up far enough?
Yeah, it was one of the first ones. Sarah, do you want to just speak to it?
Sure. Yeah, it was more your number 4 topic, like beyond carbon, reconciling climate cooling and carbon storage trade-offs. So I don't know. Now that I'm thinking about it, maybe it goes with number 2.
I think it's a separate one, Sarah.
Yeah.
I can imagine doing a really nice. It is part of it, but I think, well, I don't know. Maybe we could collapse it further, but I can imagine a perspective piece on that topic.
Yeah, and then we can always tie it in later, future years.
Yeah, I think that makes sense. I do agree. I do see how the beyond carbon could be a part of the multifunctional assessment. However, I do think that work is also a little further along. So again, a separate piece focusing specifically on that gets integrated later on down the road probably makes a lot of sense.
Pascal, there's a comment from Ben in the chat on the activity data, and I'm wondering whether this may be one of the points we should add there, both with respect to kind of activity data from a national lens, what can we see and recognize from remote sensing and so on, but also kind of more on a farm level sense, like what information does a farmer have available, or what information can we guide them to collect that would help with the assessment of a wetland? Because that would tie in very closely with the HOLAS model, and then also potentially down the road, if it became a national inventory reporting methodology, then some of this activity data that we're pulling in for the HOLAS model would have to be incorporated in some form of national surveying as well.
You know, I wanted to ask you, Roland, more explicitly what is the architecture of combining HOLAS with the National Greenhouse Gas Inventory Report? But we can have that conversation differently. In response to your now two comments, both of which dealt with emission factors, I wonder if this last one should be about like getting the numbers right, regionally specific emission factors, but not only for the wetlands, but in the context of the farms. And then part of that framing could also include the unmanaged versus managed discussion, Pascal. And that way, maybe we should take the last two that we identified earlier and collapse them into this one. And I think that would then get to Ben's interest about how do we report these, and then Roland's two comments about estimating and addressing the diversity of emission factors. I think that's how I understood it. But I would want to add to that, how does HOLAS provide the connection between farms and national reporting as well?
So there is no formal process there. The inventory group is essentially, because they're in Environment Canada, they're somewhat independent of us. What we can do is basically build components in the model that align with how the inventory would do an accounting methodology, basically based on peer-reviewed science and based on a tier 1, tier 2 emission factor calculation, for instance. Which then, because we have the model open source and transparent through the algorithm document, can become a source for the inventory. That said, our construction of the components, since we have the farmer as the user in mind, can potentially make allowances in the complexity of calculation that you couldn't implement on a national scale, which is why then the point becomes where I said, like, for instance, with the shelter belt component, where what we've done in the HOLAS model is possibly more of an inspiration to what the inventory does, in terms of that they say, okay, there is data and calculation methods, and we construct our own component out of that. Or there might be a bigger alignment, say, where the inventory says, oh, we may be able to adopt this as is. And so the more we involve ducks, say, in the process of creating this component, the more likelihood there is that we build something that the inventory later can use.
Irina, you had mentioned about merging regionally specific wetland emission factors with another topic. Can you remind me which one that was?
Of course, Pascal. I was thinking about reframing the unmanaged managed, and I think that Doug McDonald raised what I wish we had like half a day just to talk about Doug's presentation, and frankly Roland's, because It definitely caused reactions to a number of the people listening. What is managed, what is unmanaged, and some of the ideas that came up from day one. But I think all of that comes to whatever is managed, how do we do the emission factor? So I see those two connected. I do think that there's a place for a separate editorial on the unmanaged managed, and but I think one group can talk about whatever they want within that context.
Okay, well, based on this discussion, sorry, go ahead, David.
I was just going to say that the unmanaged versus managed also ties into this issue of how we structure a wetland catchment versus a wetland. Like,
yeah,
that discussion very much overlaps, and to me it's fundamental about how we can quantify or measure things in the field and then add it to the data. So I would certainly like to see that in there. But I see it as broader than simply the question of managed versus unmanaged. It's also what on earth are we talking about when we talk about wetlands? And to Doug's point about them being just part of an agricultural landscape, that's a very real issue.
And related to that same breakout group, I would suggest that what came up during the Q&A period this morning is David Lobb's comment about sharing the new evidence of the wetland-specific carbon sequestration and methane emission rates. That maybe some of the data we already have could help inform Doug and his team, and that we need to be able to pull it together. So, again, creating that evidence base it is a continuous process, and we should provide those updates. David, did you want to add to that?
Yeah, and sorry, my camera keeps dropping out. This also touches on Doug's point about the time frame and the concerns expressed about the isotopes, which I'm assuming he's referring to cesium and lead-210. I could be incorrect, but the problems with even lead-210 provided very uncertain rates of carbon sequestration back to 100 years. I'm assuming that's what Doug was referring to, but I didn't get a chance to ask about that. But that becomes an issue because a lot of the work we're doing is based on rates where we have certainty, but we don't have certainty going back 100 years. No one does. So it may fall into that same discussion you just
I think it does.
referred to.
Yeah, I think, and it must be the cesium and lead because it was the data that was shared with Doug was our data, David. So it is the cesium and lead.
I'll respond to that. I mean, it is this question about whether we're capturing sort of short-term carbon stabilization or longer-term carbon stabilization, which is what you see in a lot of the isotope work that's being done, and it's different isotopes and it's different processes as well. But what we are seeing in the peat cores that are going on, where sort of the initial the upper layers of the peat cores provide very different results than the lower layers, and it's partially because of the timing that it takes for carbon to stabilize. But just on going back to that question about what we're talking about, one of the in terms of what a wetland is. Remember, it's what we base things on is land use, right? So it becomes more complex when a wetland is integrated into a grazing environment, but when it's in a crop environment, it becomes less complicated because it is, what it's being, the permanent wetlands, and then we also have the wetlands that are actually coming in and out of production, which is another complexity of the prairie pothole region. But like that land use definition is very important. So what are we using the land for?
I just wanted to add, thank you for clarifying that very much, Doug. I appreciate it. In fact, when we go and do work in Phenoscandia, the criticism of using lead and cesium and peat is very top of mind. However, working with David Lobb, we have found that the criticisms that apply to peat do not apply to the mineral. And this is just an example of how we can curate our data and messaging to share where the data are useful and where they might not be useful. And so again, Pascal, those types of issues I think could be nicely discussed under the topic of number 4. But thanks, Doug, for clarifying that.
Go ahead, David.
Just to follow along that. Yeah, because when you deal with wetlands, peatlands specifically, the alternative is using C14 data. But the problem is C14 data, you're talking about thousands of years, which really doesn't pertain to the scope for the duration of management we're really thinking of, past or current management. So it becomes a useless tool. So you're really stuck that we can't really come up with better techniques than what you've already referred to. And I still think they're quite good for what we're dealing with in the last 100 years. But the other thing, when we talk about the wetlands being integrated into landscapes, I just happened to pull up some of our wetland survey information where we were looking at land use and land cover as well as water cover, riparian areas. And some of the landscapes, just so people understand, the prairie pothole region, I think the 3 sites we looked at, Manitoba, Saskatchewan, Alberta, they were typically about 40 to 55% what we would consider from an ecologic standpoint, wetland. Fully integrated into a cropland. Extremely integrated. So it's very important to clarify that. And you're right, there's a lot of overlap, particularly in the perennial, but certainly we get into grazing because farmers are grazing wetlands. But half the area could be considered a wetland depending on how you define it. So it is extremely important to try and get that understood so we can move forward with any of the work we're doing, whether it's through HOLOS or the IPCC accounting. It's really important.
And not to get too bogged down into the weeds here, but around, again, the question of using lead-210, cesium-137, looking at accumulation rates, we will now be able to go back to some of the Flux Tower sites that we have where we're doing real-time measurements in terms of carbon sequestration and greenhouse gas emissions. We have cores from those sites, so we can look at kind of the current real-time carbon accumulation rates versus what we're seeing from the longer-term core rates as essentially a validation mechanism to look at some of the rates that we're determining from lead-210 and cesium-137 for those areas. Off the top of my head, they seem like they're in the right ballpark at this point. Haven't gone in and done a thorough analysis of that yet, though. Sorry, sounds like someone has something to say.
I just wanted to say that the irony is that in Doug's slides, he talks about the fact that we might be overestimating, and yet whenever I present the data from the lead-210 based measurements, people in North America think that these are really, really low estimates. And so we attribute it to the local climate and everything, but it's just an interesting point. I think it's an important discussion to believe in the data. In fact, one of the major roles of our network is to be able to provide the standardized, robust, accurate measurement. So I love this discussion, and I hope that we can continue that with the team looking at number 4. So thanks for letting me say that, Pascal.
Great. Okay. Having said that, I know we're running a little over time. Again, that flex time that we've built in at the end of the day coming in handy as I expected. Are we happy with these 4 groups? And if so, then the next step would be to have some people self-identify as rapporteurs. The other option is just to set up the 4 breakout groups, people self-select, and then once in there, you'd have to essentially choose a rapporteur. I'm fine with whatever mechanism we want to take. I would certainly volunteer to place myself under number 4 with the regionally specific wetland emission factors. I think that's likely one of the places where, as an organization, we can contribute and have oversight of all the data being collected across that region. So happy to contribute in there, but also happy to work with whoever else is interested. Don't want to assume that I should be the one
Can we just
assigned
say,
as the rapporteur there.
yeah, Pascal, today's commitment to join these groups does not commit you to the long term, and it also does not mean you can't later engage another group. Let's just be clear that if you want to go to more than one, maybe we could just take a show of hands so that we have enough people in a room that has a robust discussion, and then we can figure out the rapporteur. I don't know if that's easy or not to do, or maybe we should just, I just don't want someone to have only one or two people in it.
Okay, yeah, well, let's do that. I'm not sure if I will be able to track from my computer, so hopefully we can maybe enlist Diego to help. What we could do is just go through these one by one, have people raise their hand if they're interested in participating in that breakout group, and then tally it. Does that make sense?
Yeah.
Okay. So all those interested in participating under topic 1, long-term differences in restoration versus retention and implications for prioritization and wetland conservation, please raise your hand and we'll count those up and then make sure that there's enough people to actually set up a breakout group. Again, as Irina has indicated, these are just initial discussions for charting a path forward, and really expect that there's going to be cross-collaboration across all of these. So again, you are not going to be locked in, and you're not going to be held responsible for pushing this forward. This is just to get the ball rolling on these discussions to chart out a path forward. Okay, so Diego, hopefully we have
3 people.
Okay.
Room 1, 3 people so far.
Okay. That's a good start. Okay. Now for item number 2, closing the carbon budget, multifunctional assessment. So again, this is about looking at more than just the vertical fluxes of carbon, also integrating lateral fluxes of carbon, thinking of some of the novel approaches in terms of biological carbon exports from the system, and then the potentials for integrating that into a multifunctional wetland assessment tool.
We have 6 or 7 people. No, 7 people.
Okay.
Pascal, I guess I might try to make time for this, but I think the postdoc should certainly be part of that group.
Okay. Yeah, that would make sense.
And if I could ask that, the David Aldred and Aiden and everyone who's helping look at that be part of that group too.
Okay, so we will move on to the next item, next topic, which is beyond carbon. That is the other climate mitigation and adaptation benefits of wetlands. Again, here, we're specifically initially thinking about the cooling impacts of wetlands. Lots of interest in terms of exploring that with respect to crop yields, looking at heat stress, during times of drought, and how these wetlands might mitigate some of those impacts. So please raise your hand if you're interested, and then we will set that up as a group. I'm struggling here because I would like to participate in all of these, and so again, we'll likely, if I'm not in any of these rooms and there's any place where you think information or perspective from Ducks Unlimited Canada as a conservation organization or information that we might have is valuable, please let me know. Happy to assist and contribute going forward.
We may have 3 or 4 people here. I'm saying 3 or 4.
Okay.
Because I think
4.
Sarah is also interested in second.
Okay. That's good. We have a good, fairly good balance so far. And then the last topic is the regionally specific wetland emission factors for mineral wetlands in Canadian agricultural landscapes, and part of the consideration around the managed versus unmanaged aspects of these systems. And so this is probably going to be one of the more one of the more complicated ones, but also extremely interesting.
I love there's this banging on Irina's door. Somebody wants to join the wetland project really urgently.
I'm sorry, it's construction. I'm trying to lower my hand so that I'm not double dipping. Diego, don't count me.
It's 8 people for room 4.
Okay. Fantastic. Okay. So I think we have I think we have 4 solid topics. Again, I have volunteered to be the rapporteur under topic 4. We can either have folks self-identify now for the other 3 topics, or once we break out into the rooms, then you would need to identify a rapporteur for that breakout session.
Should I open the rooms?
Sure, let's open the rooms, and where rapporteurs haven't already self-identified, we'll just leave it out to those breakout rooms to select who's going to report back to the group when we come back. So we're essentially hitting the top. Sorry, go ahead, Irina.
Can I just say, thank you to all the young people on the call, the graduate students, the postdocs, and I just want to really emphasize that this is a tremendous opportunity to join a collaborative paper, perspective, whatever, and I really am excited to see some of the names sign up, but also want to just recognize that this is open to you as well. So thanks for joining, and hopefully this is something that you could see the distance through as well. Thanks, Pascal.
No problem. Okay, so yes, we can break out into the rooms. It is essentially the top of the hour, so we're going to allocate half an hour, at which point we will reconvene and report back to the group, and then make some decisions from there on how the rest of the day is going to proceed, depending on how these conversations go.
So please, if you
Okay, well, welcome back, everyone. I know we had no problem filling out our 30 minutes with discussion. So I'm assuming we're going to want to proceed from group 1 through group 4. If that's okay, Gail, I can hand it over to you if you want to report back on the discussion that your group had.
Okay, well, I just sent it to Diego and pasted it into the chat. I have very little experience with prairie potholes, yet much of this is about that. So, what I'm not sure about is how long, and some people, the socio-economists in the group said, yeah, probably these prairie potholes have been accumulating carbon since Lake Agassiz drained. So have they, because I know we have 3,000 years of carbon accumulation in the Hudson Bay lowlands and in the salt marshes on the East Coast. So, okay. But should we be more concerned, and this is where we're fighting Doug, more concerned with the next 2 decades, because that's a time scale that's one critical for the climate change we are facing and the next generation is facing, and also critical for farm management. It's a big challenge to plan for 100 years with a farm, right? Because farmers can't plan for 100 years. And I know that's a huge question with carbon credit banking, at least in the U.S. Okay. Now, but going back 100 years could tell us something about carbon storage with climate variability. But of course, it would have to be dated somewhat, because I'm guessing the prairie potholes are much more dynamic because you go through droughts and all, and the wetlands I work on have water level control or tides all the time. So yes, understanding what's going to happen with climate variability. Now, restoration, no matter what kind of wetland it is, it's never going to restore the lost carbon stock unless you paved over it and made sure that carbon never left the wetland under the pavement. And many, when restoration is determined as a mitigation, is carbon even included in mitigation ratios? It isn't in New Brunswick, it isn't in Nova Scotia, it isn't in Prince Edward Island. At least it wasn't like 10 years ago. So other benefits are included, like will we get the waterfowl habitat back, but carbon, if carbon is included in these mitigation ratios, the area would have to be much too large to ever do that. Somebody pointed out that there's a lag period to consider for newly restored systems. So another reason not to choose restoration as a replacement for giving up a wetland, which sometimes happens. And then how deep must the soil be sampled? Somebody from Doug's group said, no, you have to sample below 30 centimeters. Well, particularly we have to get this to understand the climate variability, but also landscape variability, it was pointed out to me. And this is important, not just in biogeochemistry, but in the socioeconomic context to model benefits. So it seems like whatever we thought of in terms of carbon, socioeconomic benefits went right along parallel with them, which is nice to know. Now, and there is probably never enough money to incentivize farmers to allow restoration. And it's very difficult to even include things like nuisance cost if you're going to now make them work their way around new wetlands. And that's what we came up with.
Thank you, Gail, for doing something outside of your geographic comfort zone. That was well done. Appreciate that.
Yeah, although some of this likely does apply to some of the situations in Atlantic Canada too, because we do have questions around, for example, former salt marshes that we've turned into freshwater coastal impoundments, or returning, for example, places that were previously diked and breaching those and returning them back to salt marsh. So it's similar in terms of this retention restoration aspect.
And one challenge, I don't know if I put it in here, maybe not, but in the impact of drainage, what's difficult to tell is how deep into that wetland soil did drainage impact? And that's something I'm trying to get at with salt marshes now, with some very deep cores that Ag Canada collected for me. And what gets in the way is often that plow layer too, if you're trying to sample agricultural zones to get past 40 centimeters. So yes, we don't know the extent of the drainage impact, but that may not be so important in terms of planning for future carbon storage. And I'll try to be quiet and allow group 2 maybe.
One piece I would add to this discussion, Gail, again, so like I generally believe the theme around retention versus restoration. I think where it becomes a little problematic is when we look into the future, not knowing how climate change will affect some wetlands and the differential impact on wetlands. And is that where being able to restore wetlands that we know will continue to exist in places where wetlands might be differentially impacted by climate change, right? Does that provide additional benefits? I'm probably overcomplicating things here, but I still think that there's obviously a significant value associated with restoration in terms of all the other ecosystem services it provides in helping to adapt and mitigate to climate change. But trying to frame that in the lens of, if you're trying to pick and choose between losing intact ecosystems versus investing in restoration, that's where it becomes problematic. So
I think the idea of the potential loss is something that, well, we do think about that with salt marshes and sea level rise. There are some wetlands may no longer exist. And so, yes, providing room for them, and sometimes restoring the old ones helps. But yes, that is something to think about to maintain the active carbon sink, but it may or may not restore the loss of carbon.
Any other thoughts from the group with respect to topic 1? Okay, well, we can move on to topic 2, and I would ask their rapporteur to summarize what they discussed. And we can always come back to some of these topics later on, too, if we so choose. So if you come up with a question later on, either post it in the chat or ask it later.
Sure. Thank you, Pascal. So we discussed the necessity of quantifying lateral inflows of carbon, nitrogen, phosphorus into the wetlands, but also out of the wetlands. And at the beginning, our discussion evolved around, given the high uncertainty that we currently have, whether it's at all useful to develop or try to develop indicators for the models. And I think we pretty quickly agreed that it's really necessary now first to create data as a support to develop these indicators. And we then continued to discuss theoretically what could be potential indicators. And there were several parameters mentioned. For example, soil moisture could be a useful indicator, particularly for carbon inflows. But then again, soil moisture is highly variable, both seasonal, but also during the day at times. Other soil properties, for example, soil texture and soil organic carbon content was discussed. That could be a more direct indicator. But then again, the problem there is that the data that exists is way too coarse. So we have simply not enough data, not a high enough resolution. And we then moved on and discussed the hydrology, how important it is to understand the hydrology and differentiate in particular between overland flow of water and subsurface flow, particularly with respect also to preferential flow path below ground, and that it's really important to consider that different wetlands in different regions very, very strongly with respect to the hydrology. And so we think that perhaps the wetlands in the peripothole regions, which are very tightly connected to the groundwater, are very different compared to the wetlands at Atokas, which are mostly rain-fed wetlands, because they are really embedded in a thick Champlain clay layer. And so those two very different types of wetlands might be useful to get a more mechanistic understanding of the different controls on lateral inflows, in particular of carbon. So if you compare these two different types of wetlands. We then continue to discuss a bit the importance or not importance of inflow and outflows, lateral inflows and outflows driven by animals, in particular invertebrates. We thought, I think David Laub yesterday posted a chat where he mentioned the importance of the salmon migration as a phosphorus pump and nitrogen pump in these northern forest ecosystems. So there is definitely indication that animals do move a lot of elements of significant importance, but we are not sure whether this is important for wetland ecosystems as well. Laureen mentioned a very interesting study about a little invertebrate that moves out of wetland ecosystems into a river environment to hibernate. Laureen, I forgot the name, sorry, of that invertebrate. But yeah, it's typically, I think, overlooked in many studies. I mean, we either look at the microbiology or the biochemistry, but the macrofauna is usually overlooked by the scientific community for one reason or the other. I never really know why. We then were discussing that it was really useful or really important to actually start quantifying these lateral flows with the measurement campaign. And when doing this, it's really important for modelers and empiricists to design these measurement campaigns together, because there's always these questions that we face. As an empiricist, the smaller scale you work, you rather want to focus on one location and have more field replicates, more empiric measurement replicates, to have a better understanding of the mechanisms that drive the observations that you get. Whereas I think as soon as you want to upscale your findings, it becomes more and more important that you have actually more field replicates, meaning it's more important to sample and measure in more different wetlands at the cost of having fewer sampling locations surrounding that particular wetland. And so I think this is a very important question that we can address as a group, that we kind of try to find a sweet spot in terms of how many measurement locations and how many wetlands we sample. Yeah, overall we agreed. I think this is a really important aspect in understanding wetlands to really quantify these lateral flows, inflows, but also outflows of carbon, nitrogen, and phosphorus. I hope I didn't forget anything. Maybe the rest can add on this.
Yeah, well, so one piece I can add here is that we're sitting on data sets from work that we've done in Manitoba and in southern Ontario, essentially where we've looked at runoff entering into intact wetlands and restored wetlands in Ontario. We've also got estimates in terms of looking at runoff coming out of drained wetlands. And so that has some information, for example, on like the dissolved organic carbon and nutrients that are leaching off the landscape into these wetlands and out of these wetlands. And so again, if that's data that is potentially helpful in closing some of these gaps, I think that we'd be more than happy to make that available. We approach that historically in terms of looking, for example, at the impact of wetland loss on water quality and nutrient export at the watershed level. But I think there's lots of the process-based stuff in terms of looking at actual lateral fluxes into and out of these systems that we haven't really spent a lot of time digging into, other than just trying to extract the mass of nutrients flowing in and out. Any other thoughts from group 2?
Christian, you were on mute there when you were speaking at the end.
Yeah, sorry. Pascal, do you also have any data on subsurface flows? Because that seems to be really lacking, right? Particularly if you explained to me in the prairie potholes that these systems, they shift, right? In the winter, they actually feed into the groundwater, and in the summer it's vice versa, I think, right?
Well, so there's usually prairie potholes are generalized to have fairly minimal groundwater interaction. Now there are potentially shallow soil surface flows, but groundwater is often not considered.
Okay.
Hayashi Misaki and Garth Vanderkamp have done a lot of work around this with respect to prairie potholes, and so there is some data there, but it's not not nearly as connected as you would see, for example, in some places in southern Ontario. But we also have Ali Amelie on the team who's done some of this work. For example, I believe it's in what is it, Beaver Creek?
Beaver Hills.
Beaver Hills watershed. Yeah. And so he's also done some work documenting, kind of the subsurface connections between wetlands and watershed outlets. And so it's not to say that it can be significant, but there's not a lot of people who do direct groundwater measurements in prairie pothole wetlands.
Just a clarification, because you can see the fill and spill phenomena between wetlands, and it's often a very shallow subsurface flow, like within the top 10 or 20 centimeters. And you can see that in the spring, water is seeping through over the surface, and it's clearly running in the shallow surface materials as well. I don't know if Genevieve Ali is still on the call today, but she had also done some of that work in Broughton's Creek.
Sorry, I literally just arrived because I was working. And I'm still not home, so I'm going to reserve my comments from later because I'm still in a noisy place. But it's difficult to measure is the short answer, I guess.
Yeah. But there is some understanding of how they are connected through what I would consider shallow subsurface flow, not groundwater flow so much. Not at the time scale that we're talking about.
What do you mean? Not on the time scale that we're talking about?
Within months or a few years, they may be clearly affected over hundreds to thousands of years post-glacial, but not necessarily on a management time scale of months to years.
Yeah.
Last call for additions from Group 2 before we move on to Group 3. Okay, well let's move on to Group 3, who were covering the topic of beyond carbon and looking at some of the other climate mitigation and adaptation benefits of wetlands.
So I would like to acknowledge Sarah Knox as our designated lead. She had to leave for a meeting, and so she asked if I could report on her behalf. I'd also like to acknowledge Betty, Baxter, Larry, and myself for being part of this group. We talked about the idea of writing a perspective that looks at a conceptual synthesis of how freshwater mineral wetlands, particularly those with varying vegetation cover, influence surface energy balances, specifically the sensible and latent heat fluxes, as well as albedo. The paper would argue that we must move beyond carbon-centric ideas and metrics towards integrating both the biogeochemical processes, which focuses on the carbon-centered part, but also the biophysical, which focuses on the cooling part. We talked about, first of all, we spent perhaps the first 10 minutes of our breakout group talking about the fact that perhaps the word trade-offs was inappropriate, that it's not either cooling or carbon benefit. It could be both and it could be neither. And what really came to the fore was that there are very homogeneous systems of wetlands. They're predominantly open water with very low leaf area index and low carbon, versus other systems that are also homogeneous but covered with emergent vegetation with high LAI and high carbon storage. But there's also the whole spectrum in between of heterogeneous systems, and that we're trying to understand maybe across that gradient what the implications would be for the carbon and for the cooling benefits. We talked about in a perspective paper showcasing case studies, and it was agreed that there would be 2 case studies, one called the Frank Lake Basin in Alberta, where there are basically 3 wetlands. 2 are similar and 1 is very different. And then there's also the one in Manitoba, and we don't have a name for it other than Pascal's 3 wetlands. And so those would be the ones that we would compare and contrast. And we would look at deriving comparative metrics, including remote sensing metrics, and Larry mentioned about moisture indices, water indices, albedo, but we would also look at the flux towers with the net ecosystem exchange, but also the methane measurements and the modeled latent and sensible fluxes. So I want to be clear that this is an open kind of invitation for anybody interested in contributing to this to contact Sarah by Teams. Just say, I want to join your group. And Sarah will gather those names, and then we plan to have a regular meeting, not right after this meeting, maybe 2 or 3 weeks from now, but one that would be ongoing after that. We also will set up a regular a OneDrive so that people can contribute ideas, data, and references. as well as anyone who is really excited about the creative part of it, data visualization to really showcase the differences in these open water, vegetated, in between, and the consequences for both the carbon and cooling effects. We also had 3 key references that were identified, and I forgot to mention earlier that this kind of work has been done in peatlands, and maybe Larry can chime in a bit about what that work has been. But he felt, we talked about at first, should we compare the freshwater mineral to the peatland, and Larry advised that we should really focus on the freshwater mineral one because nobody has really done that yet. And there's also a paper that not only for peatland mineral comparison, but trees and forests and their role in cooling as well as freshwater mineral wetlands. So different ecosystems have done this. I think it's time to uplift freshwater mineral wetlands to do this. And as you can tell, we're all really excited about it. But I invite Betty and Baxter and Larry to offer any of their if I missed anything or anything they want to emphasize, I'd appreciate that.
From my perspective, you covered it very nicely. Thank you.
Well, thank you. Appreciate that, Larry. I do have the notes, and I will share them to Diego. So Diego, one of the outputs of the AGM will just list groups' notes, and people can go and explore. And if they decide later on they want to join, they can, or if they can opt in or out. But it's up to everybody's self-interest and capacity to join these groups. Sarah, are you back yet? She said she was going to come back in 1 minute, so I think she just missed it. That's it from us, Pascal.
Hey, thanks for that, Irina. Okay, so I'll cover what we discussed in topic 4 under regionally specific wetland emission factors, and then considering managed versus unmanaged. There's going to be limited notes here because we completely got bogged down in the managed versus managed conversation, which we think is probably going to be the most important piece to address. And so some of the context here is, off the top, we covered the fact that we think that there is generally good data coverage now to actually come up with regionally specific default emission factors, whether that's around greenhouse gas emissions or carbon stocks for these systems. We have now generated substantial information across the country, some of it through CAF, some of it through earlier studies, that I think we can easily break these out into regionally specific default emission factors. Where the rubber hits the pavement here is going to be working with Doug's group to figure out what is the simplest way to integrate these into national greenhouse gas inventory reporting, and that is going to be dependent on that consideration of managed versus unmanaged. And so one of the first places that we started talking about was cropped wetlands. There was some discussion around, what is a cropped wetland? Often here, at least within the prairie context, we're talking about class 1, 2 wetlands that are completely cropped through, and how you associate emission factors with those, map those, but then report on them easily in a national inventory greenhouse gas report at the landscape level. We had a little bit of discussion around, and one of the other low-hanging pieces of fruit with respect to managed wetlands are those that have water level control structures. So anything with a dike or dam essentially is managed in terms of its hydrology, so easily integrated into that reporting framework. The main issue there is that is one of the areas where we do not have a lot of information in terms of greenhouse gas emissions and carbon stocks. And so, we chatted a little bit about some of the large legacy projects that DUC has across the country. Again, those are projects that we generally have low information with respect to ecosystem services, including things like greenhouse gas emissions and carbon sequestration. But so again, most of the conversation came back to working to develop a simple framework around assessing managed versus unmanaged and how to report on this. And so I don't want to throw Doug under the bus here, But one of the requests that I made is, we went through an exercise where we opened this up to scientists, with respect to what we would consider managed versus unmanaged. And while those are important perspectives, we likely probably overcomplicate a lot of that. And so one of the requests I had is whether Doug and his group could come up with essentially a simple schematic of how they would like to see things reported. When there's, for example, wetlands in cropland or wetlands in perennial cover, and essentially the conversion between those systems. Once we know that, I think we have all the information in place to come up with a relatively easy way to calculate emission factors and to integrate that into national inventory reporting. And the one additional piece that I would add here, we got really deep into the weeds on this conversation, so we got pulled back into this group before we finished off. But one of the things that I think we can do is, again, I think, so we were careful to discuss that, in the national greenhouse gas inventory reporting, we're not being explicitly, spatially explicit with respect to reporting for individual wetlands, but the information that goes into that national inventory report and the scaling of it can come from these more spatially explicit studies. So, for example, there are a lot of watersheds where we have detailed information on wetland inventories, cropped wetlands, wetland loss, where we could go in and essentially apply the framework that Doug's group is interested in seeing and develop that with the extensive information that we've collected for all these sites across Canada to see how that would work essentially in the national reporting inventory context. So Doug and David and others who contributed to some of these discussions or points, please feel free to jump in, correct me if I've gone off the rails anywhere. But again, I think the long and short of it is that understanding how we're going to integrate and assess whether wetlands are managed versus unmanaged is going to be extremely important to the basis of developing regionally explicit default emission factors that could be incorporated into national inventory reports. Hopefully I haven't misrepresented anything, Doug.
Hey, I'd like to just add one comment, Pascal, because as scientists, we're all discussing details, etc. But I know exactly the position Doug's in for my work with Ag Canada. I think it is very possible, with further discussions with Doug's group, to have a very clear idea of what they need and make sure that we're generating, although it may be very detailed and spatially explicit based on our research, provide the information they need to allow them to move forward, making assessments and tracking change over time. I know this comes up with all the erosion and other indicators to do within agriculture. It is possible. We just have to make sure that what we're generating feeds into that. So this communication about what exactly they need, whether it's a schematic, tabular form, or whatever, is critical to make sure that over the next 2 years, we're moving in that direction. And if we know exactly what direction we're moving in, we should be able to, every time we meet, piece things together to make sure that we are providing exactly what they need. And to make sure everyone's expectations are realistic. No one's going to be 100% satisfied because it is a compromise. It's a compromise that they always have to do in policy, make science fit the policy demands. And I've sat in on the stupid IPCC meetings, and they are brutal. And he's right. They're very strict protocols on what can go in and what can't. It's not up to Doug, and it's just the way it is. But I think we have to work really hard. But the only way we can work really hard is if we have a very clear idea of what the rules are for what can go in. And this also applies to the work on HOLOS too. HOLOS has very strict rules of what they can do based on practicalities. But we need to know very clearly what those rules are to make sure what we're generating and what existing data may be available can fit into those rules so that they can get better information. Is that fair to say, Doug?
Yeah, I mean, it's not like I don't think it's that restrictive. What we need to know is what the emissions are to the atmosphere that are caused by human actions, right? And part of that is knowing how much carbon there is at one point, and if you change the conditions, then how much carbon will there be at the end point or the other point? And that's what we don't know. And I realize Pascal's saying, oh, you've produced a lot of data, but I know it's also just being like the contribution agreement finished in 2024, right? So I don't expect like a landslide of new science. I expect, there's some new stuff out there, but I mean, it's great to hear that we can, continue to add to the data that we've already got from you guys, and we can see what actually has been produced in recent years, and that would be fantastic if we can add to what we've already seen in the literature so far. But I mean, you guys don't have to come up with all the answers. Like, we just did sort of a stock take of what we know about prairie potholes, and we know where we're at. And science doesn't happen overnight. So we don't expect things to change overnight either, or in a couple of years. But we do have to come up with, as I said, a simple way to produce estimates associated with the change that's occurring, that's resulting from agricultural actions. We want to limit it to, one driver of change, and that those estimates are not a misrepresentation of the emissions that are really occurring to the best of our knowledge. We can always be wrong, but we try to avoid that. I personally, one of my rules for not reporting something in the inventory is if I think it could be the opposite, then I won't report it. It's one of the reasons that land use change to urban environments isn't in our inventory yet from cropland. It's because we're not sure if there's a positive or a negative that occurs there. So the example that I always use. But that's the important that we're getting, if it's a positive or a negative, right? There's always going to be uncertainty.
I see Irina has her hand up. I think someone else may also have a question, but we can go with Irina first because you're the only hand I don't know if I see. You're listed as hand number 2, but I don't see hand number 1. I guess that's the issue for me.
No problem. I just wanted to respond to Doug's comment, and I would say, as having been the person to synthesize the literature that we did for the 2024, there was about 110 journal articles that were synthesized. With this network, since we started, and many of the papers just coming online now, I was asking Diego what the number was, but I think we've already produced 30 papers, and there's like a small tsunami of papers being put for submission right now. So I would say that we have transformed our way of thinking based on the recent data, and these are not just sitting on the shelf data or on people's notebooks, but actually formed into papers that are in quite influential publications, including Nature series, Global Biogeochemical Cycles, and others. And so what I would hope is that we can work together to give you our leading in a way that could be best received by you. the leading edge of our findings. And so I'm not saying that you take them all and implement them, but just to be aware that our knowledge is rapidly evolving because of this network. We're very proud of it, and we can imagine that that's only going to continue, but we want to be able to, because we care so much about impact, and that means helping you with your national greenhouse gas inventory reports and helping Roland with HOLUS, we need to be razor sharp on what you need so that we can provide that information to you.
And understood. And I think, I suppose access to the data that's being produced is what we need.
So just to extend this topic a little more, so Doug, we went through that exercise of interviewing and polling experts in terms of managed versus unmanaged. How do you see that going forward? Like, is the plan to integrate some of that information and then for ECCC to make a final decision on how it's going to assess managed versus unmanaged wetlands? And where I'm getting to with this is where I was landing in our breakout group, and I'm not trying to throw Doug under the bus here, but one of the requests I made is, could there be essentially, the production of, a diagram, maybe even a graphical abstract to demonstrate exactly how ECCC would like to see wetlands accounted for in the National Greenhouse Gas Inventory reporting, with respect to whether they're embedded in cropland or perennial cover. Essentially a diagram that would then allow the people producing the science and these estimates to figure out the best way to break these out regionally and to factor them in the simplest way possible to be included in the National Greenhouse Gas Inventory reporting. Maybe it's just me being a little more of a visual learner and sometimes learning from these graphical abstracts, but I think actually having a series of diagrams showing like the conversions and the things that are of particular interest to ECCC in terms of capturing in the inventory would likely be really helpful to help people conceptualize and then figure out the best way to bring this information and incorporate it in the simplest way possible for the National Inventory Report. Yeah, I'm getting a thumbs up from David, so I must be on the right track.
Yeah, no, I mean, that's not a problem. It's something we can definitely produce. I mean, Matt sent me a really good paper that demonstrated differences, like actual differences in fluxes between different landscape types. I mean, that's what I was talking about when I was talking about whether there was information that had been produced during that scan of people's impressions about managed or unmanaged. Like, I would hope that maybe that scan or that discussion maybe helped to inspire that paper, or maybe the paper was already in production. But I mean, these are the questions that, like, part of the value, I think, of doing that survey was that people understood where there's knowledge gaps. Yes, it's not a problem to develop I mean, you saw the pools, right? there's lots of visualizations of what's required to produce estimates.
Yeah, and maybe I will take that on as an action item to follow back up, create a group. I'll open it up to whoever wants to be involved, but to try and keep this moving forward so that we're making sure to start assessing the information that we're collecting through this lens to figure out how best to use it within the National Greenhouse Gas Inventory framework.
And obviously,
Roland will work with I see synergies here between the National Greenhouse Gas Inventory reporting and HOLOS in terms of incorporating this at the farm scale. So I think there's some synergies there that we can build into this.
Yeah, I mean, we can, I mean, it's always, so to say, the assumption that the inventory might be somewhat more simplistic than the HOLOS model, but we can definitely start at where the NIR is at and then go from there to say, oh, but we could also do X, Y, Z because we get data directly from the user.
Doug, I'm curious how the cropland people are feeling about this decision with the wetlands, because they're typically creating their own estimates, and I guess one challenge is going to be convincing them to take wetland numbers and put it into their inventory. We're talking about that here too, the challenges with that. Do they have their own model already? And is it even possible to do like what you're talking about without double counting?
Yeah,
the D word.
So it's good. We're a bit more integrated than the way that you guys function in the States. So we work directly with AAFC, the group that produces the cropland estimates. So yeah, we can do the initial conversion, and we transfer data back and forth all the time. So it can be done. I mean, there's not a lot of other choice where like any land conversion where if it's forest land towards cropland, or it's wetland towards cropland, or it's settlement towards cropland, never happens, but the emissions end up being reported in the receiving land use, right? Like deforestation emissions to agriculture are reported in cropland.
Pascal, might I suggest that we take this incredible day and maybe wrap up the discussion and focus more on the AGM for next year. I do have a couple slides to share. Does anybody still want to speak to any one of the four? Remember, we are a very inclusive group. And again, for the young people, early career people, and the older ones like me, if you're interested in something, you are welcome to join. You'll have to work, but you are welcome to join. And so don't be shy about indicating your interest on any one of those formerly 7, now 4 topics. And there will be other ones. And David Lobb, I do want to follow up with you on the one about the salinity and using the approach that we used with the Strahler stream order. That might help there. I'm excited to do that. But at this point, if nobody wants to continue the conversation on this group 4, might we switch gears a bit to talk about the next AGM? How do people feel about that?
I think that makes sense, Irina. The only request I would make is that maybe between the groups that have discussions is to formulate and think over some action items. And so I know I'll be reaching out to a few members of the group, and then of course we'll try to open this up to the broader membership as well. But I think one of the main goals here again with this year's AGM was to increase cross collaboration and to start pushing some of these more, overviews in terms of perspectives and synthesis of all the data that we've collected forward. So I would encourage everyone to try and take away a few action items to start moving and working with this data as we move into the final years of the CAF project. And so with that, happy to turn it back over to you,